Some findings are so common that we don't even report them anymore. You can think of calcifications in the pineal gland on CT or cysts in the choroid plexus on MRI. And cysts in the choroid plexus on MRI remind me of this buncha balloons, which is a device invented by a father to fill up a lot of water balloons at the same time. There are two types of choroid plexus cysts. The first one are fetal choroid plexus cysts that are seen on fetal ultrasound, so we as radiologists don't see them very often. They decrease with age and have usually regressed at birth, and they're not real cysts. They're made up of mesenchymal stroma distended by cellular debris, and there's no epithelial lining. The kind of choroid plexus cysts we see are adult choroid plexus cysts, which are slightly hyperintense to CSF on flare, and they increase with age. And during aging, there is atrophy of the epithelium of the choroid plexus with thickening of the basal membrane and fibrosis of the stroma, and there's less microvilli, and this leads to the formation of these choroid plexus cysts. Sometimes you can see the term xanthogranuloma, which are filled with very fatty histiocytic material, and there has been some debate if xanthogranuloma are the same as choroid plexus cysts. And there was an article in Radiology 2006 by Anne Osborne, who's really an authority on neuroradiology, stating that most choroid plexus cysts are actually degenerative xanthogranulomas. And you can see on this post-contrast T1 weighted image the rim enhancement of the choroid plexus lesions. When you look at how the choroid plexus is built, and we talked about this in the previous videos, so you have the stroma made up of connective tissue with capillaries lined by endothelium and an endothelial-derived basal membrane, and the stroma is surrounded by epithelial cells with also a basal membrane, and these two basal membranes together with the other components form the very complex filter that filters the CSF. We talked on how the pia is invaginated in the choroid plexus when we talked about intraventricular meningioma. And when you think of these cells, these xanthoma cells that are filled with lipids, so a lot of lipids in their cytoplasm, they are thought to be derived from leptomeningeal cells that differentiate into fibroblasts and then accumulate all those lipids in their cytoplasm. The foamy histiocytes with all these lipids are located under the epithelium of the choroid plexus, so not in between the villi. And this histology has been acquired in a child with symptomatic bilateral choroid plexus xanthogranulomas. So usually choroid plexus cysts are asymptomatic, but in very rare cases they can lead to, for example, hydrocephalus. And these are the preoperative images of this child I just showed the histology from. So you can see very large lesions located in the choroid plexus with high T1 signal. And post-operative with intracranial air, you can see that the choroid plexus lesions on the left side have been resected. When you look at higher field strength, you can even see the choroid plexus cysts a lot better. And one of the first videos was on Alzheimer's dementia on MRI, and I talked about amyloid beta and tau. And these two proteins are key proteins in the pathogenesis of Alzheimer. And the brain can get rid of tau and amyloid by transporting it through the choroid plexus in the CSF. So during aging, I already said, the epithelial atrophy, the thickening of the basal membrane, the fibrosis of the stroma, the decrease in microvilli leads to a less functioning choroid plexus, and there's less clearance of tau and amyloid beta in the CSF, and this can contribute to the pathogenesis of Alzheimer's disease. And I usually don't report choroid plexus cysts in my report because they're so common. And it's also because articles like this are very interesting from a pathogenic point of view for doctors. But if you put choroid plexus cyst in your report and then the patient starts to Google it and finds something like this, it might become very worrisome and very threatening. And the patient may get anxiety or lose sleep over it. And if we know one thing about Alzheimer's disease, what's important is that you should not lose sleep, because during sleep your lymphatic system becomes activated and the brain can get rid of the waste products. So in the next video I'm going to continue with the lymphatic system, and I really hope you do stay tuned.